I'm going to talk a little bit about Quarkus 3 and Java 21 and OpenJDK virtual thread, aka Project Loom. So just quick question, how many people actually have some hands-on experience with the Quarkus so far? Okay, a few. Okay, and then how many people are not Java developer are here? Okay, interesting. Alrighty, okay. So I'm guessing the rest of them is Java developer, not Quarkus experience, which is the Spring developer. So my name is Daniel. As just echoing, is it still working? Okay. So echoing introduction, developer advocate at Red Hat. Some echoing here. And Java champion. I'm based in Boston, United States. It's a long flight from Boston get here. I fly through Dubai, but luckily there's no flood anymore. So I luckily safely and then lay over Dubai and get here, Bangalore. And I do a bunch of stuff here. And then here's my social media handler, Daniel30, not 29, not 24. So there are many Daniel. So you can find me, Daniel Brody Hand, and then like an agent face. It's pretty much easier to remember me as well. And you can reach out to me any Java questions and cloud, Kubernetes, and like a GitOps serverless service mesh and like a more like a CNCF stuff. And I'm more than happy to help. So here's just quick in mind how Java thread working on that. So when you run Java application, doesn't matter job file, WAR file, EL file, or running on Tomcat, JBoss EAP, or any kind of engine, you can run the application. It literally creates a new process, and the process brings into multiple threads, and then it's running on and processing your application. So whenever you brought up your Java thread stuff, and then it's related to your platform thread, which is the operating system thread. It tie in your infrastructure, which is your local machine, like a Mac OS, Windows, Fedora, RHEL, any kind of your computing system. So back in 1997, if I remember correctly, we have new Java thread, aka green thread. So with that, the JVM actually could manage your thread at a time rather than your operating system. It was really great because you can manage your thread by JVM pretty much easier, which means developer standpoint, you can make a programmable way to develop the Java thread. However, the hardware actually kept evolving. For example, you were using the one core the CPU stuff at a time, like 2000, and then the hardware changing and evolving like a two core and third core and a quad core and an eight core, many cores. But with the green thread, you cannot use that multi-core at the same time. So there is some limitation and constraint when you're using green thread back in 1997 and until 2000. And then the JVM, they changed the architecture from green thread to platform thread, which we were using until Java 19. And the Java 19 changed in a new concept based on OpenJDK project, which is a Project Loom. So now your thread can be managed by JVM back to the like a green thread concept, but it also optimize and consume your old platform resources at the same time. So if you still stick around the older version of Java, for example, Java 11, Java 17, you have a zero chance to use this kind of stuff. After this session, okay, that's cool. I mean, let me try to that. But if you're still using Java 11, 17, you cannot do that, unfortunately. But if you're using Java 19 and 20, you can use that. As long as you enable preview feature on JDK. And 21, the Project Loom is default. So you can just use that, any kind of extra compilation. So what matter the virtual thread, and just a little bit deep into your programming model, which is a non reactive application, pretty much Azure explicit. You can just process request response synchronously over the internet or HTTP protocol or TLS termination. So this is one of the example, like a non-reactive application, you can say imperative, and then just going to endpoint like a REST API, and then you can return some kind of obvious object like a string, array list, or collection, some of the object directly return. So non-reactive application, something like that. On the right-hand side, this is how it works. So the developer, you don't need to worry about how thread is creating and running because this is not your scope. You just implement business logic, and the Java framework actually take care of that for you. So this is literally happening underneath the platform thread, just like a OS thread. So when you create a new application, and then you can call that like a HTTP request, and then when you create a new HTTP request, and then it tries to create a platform thread on your JVM, and then so process your application. And then the application is not standalone. You have invoking external services, for example, database connection or messaging broker processing or store your file, some storage, something like that. So whenever you have some external service, maybe you can say IO operations, and then your thread needed to wait for the return. So I'm going to just save my file in my Oracle database or MySQL. I needed to waiting for the return. And then after I got return, I'm going to just resume rest of my job. That's really happening in the non-reactive application. However, you cannot say I have just one application for the next 10 minutes. So over the internet, and then there are a lot of the end user, like a human being or IoT edge process or AI bot or third-party application. There are many kinds of applications keep calling your business application. And then first request just arrived and create a new platform thread and the processing the data transaction. In the meantime, the second request also arrived at, and then the first platform thread already busy, and then how deal with the second request. So operating system, CPU, okay, let me try to schedule new platform thread for you, the second request. And then create a new thread based on your memory resources and then assign to the second request. This is really happening. That's why when you develop non-reactive application, and then you have limited resources for specifically concurrency application, because you sometimes I have maybe 10,000 requests per minute or even per second. And then my hardware is a limited resources like a CPU number and then memory size as well. So that's actually reactive programming was born to fix this problem. So you don't need to keep creating new thread for your request, even if you got an IO operations. So instead, we're going to keep reusing existing thread, just like a data connection pool stuff. So the reactive program says that they don't call platform thread, they actually new name on it, like event loop, but this is really platform thread. So but you don't need to create multiple and maybe 100 platform thread, just a few platform thread you just keep reusing. Just like a right-hand side, when your request coming out, and then you're gonna try to remote service it, like some store your some text file in your storage. In the meantime, the second request arrived, okay, and then I'm gonna just looking for the available event loop, which is the platform thread as well. You got a question? Yes. Yeah. Very similar. And or Vertex instance as well. Something like that. So one challenge for that, the really good question though. So for developer standpoint, okay, this is a really cool concept. So how to develop React application with Java or any other language platform. And then more important thing is how to migrate existing my application from non-reactive to reactive stuff for this performance and concurrency. So for example, Spring Boot, I assuming a lot of people Spring people here, and then Spring the ecosystem like a Spring Reactive and the Spring integration. But sometimes you're going to implement Spring Function, Spring Cloud in case you want to connect to like a Kafka cluster. And then, so Spring Reactive is the Spring Mono and the Webflows stuff is totally different. You cannot change some of the code of line for reactive thing. You need to rewrite every single detail. And then the more important thing is just like you need to save some of the status your application when you hit IO operation, and then you need to come back and resume rest of the job. How do your application know what is the rest of the job is? That is the continuation. And then there are several ways to implement continuation. For example, like a callback function or routines or some of the other frameworks. So they are actually Spring Reactive also call different stuff. So this is all kind of stuff you need to subscribe and mapping. This is also some of the way how to implement reactive action and continuation stuff. So this is a not easy part. Even if you have more than 10 years Java experience, maybe, oh, what the hell is that? And then, okay, I'm going to go back to the normal Java apps. Or sometimes, okay, we're going to take the new framework, like a JavaScript or like a Vertex or the other thing, okay. And then your company are not going to give you more than 6 months to learn something about that. Just give me the 2 weeks and then make that happen. But never ever happen. So this is the big challenge for Java developer for concurrency because the operation team, okay, so our new system, we have millions of the requests at the same time around the world. And then how to process that traffic. Okay, we have some like a distribution system and architecture, and then we're gonna have some new messaging processing platform, which is a Kafka or Apache Pulsar. And then we are ready to go for platform layer from platform engineer or IT operation team. And now we need to change the application as well, like a Java application. But that's not going to happen in a few days. So that's really happened, the Project Loom, the reason why Project Loom was born. And the one good golden rule for reactive programming, never ever try block the IO thread. That is that if you block the IO thread, and then your event, the reactive application is actually broken. So here are just some bullet points to compare between non-reactive and reactive application. So reactive application is pretty much easier. So whenever start the Java app dev, so you can start with the hello world, and then like some less endpoint / hello, and then you return hello world. You start your application dev. So that's really non-reactive application and imperative application. Pretty much easier to develop app, learning very easy. And the big problem here is expensive. For example, Linux operating system, whenever you create a new platform thread, it averagely is a 1 megabyte for like a platform thread. And the 10 millisecond, which is just new scheduling by CPU, like a context switching, something like that. And the limited concurrency depends on your infrastructure, my laptop, your desktop, or your some cloud environment, something like that. And reactive is a pretty much efficiency for resources management and high concurrency, just like two event loops, which is a platform thread. And some people ask me, hey, Dan, how many event loop, like a platform thread, I need to create for my based on my operating system? So, for example, Linux operating system is the same number of your CPU cores. So if you left out like 8 CPU cores, you probably create 8 platform thread for event loop. That is some like a common average numbers. But based on your application concurrency level, you need to tune like a more up or down, something like that. So there are some pros and cons for each program model. And now, so virtual thread, like a Project Loom, there are also sub-project often JDK 21, like a Valhalla and a structure concurrency API, and a lot of stuff there, like a pattern matching stuff as well. So the virtual thread actually combines the good thing and the get rid of bad things. So you can sit in the good thing in the same place, keep doing simple app dev, and then we wanted to have resource efficiency and high concurrence at the same time. So here's the thing. Okay, that's cool, awesome. Okay, how do I do that? And then how can I start? And then a lot of people ask the same question. And then there is basically technically you can actually use directly virtual thread implementation from JDK Java 21, which is, for example, you can implement interface directly, or you can create the factory facade to make some pooling virtual thread as well. But it's sometimes not easy to make that happen. Sometimes you have more than 10 years Java experience, maybe it could easy. Please don't try to ask for a chatbot box or something like stuff. So interesting story. So I have a bunch of the application at demoing. I've been using a lot more than 15 years of Spring Boot, and recently I'm using Quarkus as a Java champion. And then I have some Spring project and try to migrate from Spring 2.x to 3.2. And I just try to ask for AI-powered tool. I'm using three tools like Copilot, and then IntelliJ AI Assistant, and then Amazon Q, and also some few among others as well. And then when I ask the Copilot, hey, and then also JetBrains, the AI assistant, hey, I need to migrate my Spring 2.x project here. I just import and then migrate to Spring 3.2, and then the AI power said, oh, yeah, I'm sorry, there's no Spring Boot 3.2. It's not released yet. But that's not true. So modeling is not up to date based on your maybe which model, which API, which AI tool you are using. So sometimes you cannot have your answer from AI bot. And I saw a lot of talks this conference AI stuff. And then I went there to QCon Paris a couple of weeks ago. There are a lot of session and workshop around AI and the dev nexus as well. But I'm still not mature to do that. Anyway, so Java framework actually provides some kind of capability to allow you run your application on virtual thread. So here's a Quarkus application as an example. So you just need one single annotation, which is it's too small. Hopefully you can see that. Annotation run on virtual thread. You can put in the that annotation on method or on class level. If you put on this annotation on class, all method inside the class, that method will be running on virtual thread. Pretty simple. Just one annotation. The behind the scene, the Quarkus team, engineering, and the individual contributor actually keep putting more efforts and time to make all Quarkus ecosystem friendly in virtual thread stuff. Doesn't matter HTTP or gRPC or messaging broker or Kafka topic, any other stuff. So now you can see that the virtual thread on the right hand side. So we're going to keep creating virtual thread. If you have some experience to use like a virtual machine, and then virtual machine is based on your physical server, like a bare metal. And then, so hypervisor is some kind of software to create a virtual machine on top of the physical server. And then, but it's you can create more than the number of your hardware resources, like a CPU memory. For example, you have a 16-core CPU cores, and then you're going to create a 2 vCPU virtual machine, and based on mathematical, okay, I just created like a 64 divided 2, which is 32, but you can actually create more than 100 virtual machines. Because your virtual machine won't be consuming 100% the CPU resources all the time at the same time. So you can keep overcoming, creating that thing. So it's a similar thing. We're going to create a virtual machine whenever we have a new request. And then that virtual machine not block the platform thread. Here's just some interesting thing. So Project Loom also named the new name for platform thread, which is a carrier thread. So, but all platform thread, which is operating OS thread. So platform thread, previously we call platform thread because it's a reliance on your operating system. That's a platform. And now the reactive programming, okay, we changed the name because it's not same concept of a platform thread. So that's they rename on like an event loop. And now here the Project Loom also name on in like a carrier thread. So we're gonna keep creating virtual thread, even if you got a IO operation or calling external services, and the virtual thread is not gonna block the platform thread. And then, so second request, we're gonna recreate the new virtual thread. So virtual thread, one big rule, just like we create, and then not gonna reuse. Your job is done, and then we just deleted the virtual thread. Not gonna reuse, just like a messaging concept, like a fire and forgot. So this is a very simple. So, and then again, question? Whenever you got a new request at the same time, every time we're going to create a new virtual thread. It's to create a new virtual thread. So when you hit the like a so virtual thread, so basically you gotta hit the external services. You say IO operation, but that's not gonna block your platform thread. So platform thread is still available all the time. So that's why the platform thread keep release the resources to virtual thread based on JVM scheduler. Yeah, so that's the virtual thread stuff. And then again, so carrier thread, like a platform thread, is not only one. You can actually multiple carrier thread. So, and then there are some like a fork join concept. So sometimes you're like a platform, like a carrier thread, super busy to manage maybe 1,000 virtual thread. And then at a time, but you still good enough resources on your CPU and memory. And at a time, okay, JVM create a new carrier thread for processing next coming up the request stuff. So let me try to show a little bit quick demo. And then but for that, this is a code snippet. In the left hand side, this is just blocking app, like a non-reactive application. So just try to some data from database, which is a PostSQL. I'm going to use that, and then just retrieve all data. Pretty simple. The get method, and then reactive application. I change a little bit, like some based on Quarkus small ride project, which is like a little bit Spring reactive stuff, like a mono web blocks. Here is a uni and multi. Uni is a single event, and a multi is a stream events. And then here is some how to implement continuation. And then the middle of side is a virtual thread, exactly same application code compared to non-reactive application. And one different thing is I just put on the one single annotation, run on virtual thread in the middle of the side. So here's my GitHub, the Daniel 030. So you can go to the Daniel 030 GitHub and then YouTube channel and then Twitter, LinkedIn, and you can find my old stuff. This demo actually available publicly right now. Okay, so this is my best bet resolution. So if you cannot see, yeah, please come to me after session. Let me show that. Okay, so I have some few projects. And the first to do application, and then so just it's Java entity, like some data transition Java beans. And the one of the good thing is the little bit different thing is between our Quarkus and Spring Boot. So JPA implementation, the Quarkus actually based on oops. Okay, go back here. So implement JPA implementation. So Quarkus actually implement a Hibernate ORM and with a panache. So when you implement JPA, you actually put in some getter setter and then fundamental operation. delete my data, insert data, and update the data, create data, and also you have some SQL file to create the schema and create the index sequence, etc. That is just some known knowledge. How do you implement JPA with Spring Boot? And Quarkus actually get rid of that kind of stuff with that library. So one of the big goal of the Quarkus is the increase developer productivity. It's not a good, not a huge stuff. So just we focusing on developer daily job. Okay, so what do you do every single day? Writing code, testing code, and then build code. And if you got some error, and then you back to the code and then change the code and then fix the problem and then back to the code. And then you're done, you just push and commit. Your job is done, and then enjoy your dinner. So this is really happening every single day. And then in order to do that, you need to keep doing some repeatable job, like a compile, maybe build, maybe verify, or you're going to use some fancy UI on IntelliJ. So we're going to get rid of that kind of stuff. The Quarkus provides the live coding, which means you don't need to rebuild, recompile, restart. It automatically done that, just like a JavaScript. And then continue testing, make available whenever you save a file. It automatically invoke your unit test, and then you don't need to call some third-party company. And this is pretty much easier. And then the test container is also built in out-of-box feature. So Quarkus Dev Service, for example. So this is a Maven project, by the way. And then I just print the Hibernate ORM. And then JDB support GraphQL, which is for connect to PostSQL and Hibernate ORM Panache. And then Jackson to consume and produce JSON file format. That's it. Pretty cool. And then the to-do entities, I don't see any kind of like a getter setter or some of the stuff. It's already there because when I go to the penalty extension, and then they are all implemented automatically. And then when I get the resources file, which is like a Spring controller, and then so you can see that the to-do by entity, and then just the list all and the create all is automatically just code it rather than implement myself. And then when I go back to application property, and I have nothing, zero. So that's why zero configuration. And then of course the SQL file, I don't have any create like a DDL stuff, like a create schema. So I just only print the data with insert. That's it. And then Quarkus Dev Service automatically stand up your PostSQL and a lot of container based on test containers. And then it automatically create and drop and then insert data and create the schema automatically. So let me go to terminal window and then go to do app. And then here is, I don't have any process right now. And then let me try to run Quarkus Dev. You can use a Maven and Grad command line. I'm going to open new terminal window here. And I'm going to try doc process here. And now I have one PostSQL is running automatically. When I stop, my Quarkus Dev is automatically stop as well. So when I go to landing page, you can see that I'm just to do my list, and a little bit awkward here. I just explain Quarkus imperative and Hibernate Panache. And then back to my terminal window, and then my first application is running on executor thread, which is a platform thread. And then I just check it out. I just done, and then Quarkus.io. You can find more tutorial. Quarkus.io here. So Quarkus.io, and then you can find all kind of extension. Go to extension more than like a 700 stuff. And then we have some new extension like a LangChain4j for AI. So you can actually develop AI programming rather than just consuming, and then connect to like an OpenAI or the Hugging Face or Mistral, bunch of the stuff. Question? So we have okay, just two things. So I'm not going to say Quarkus is better than Spring Boot. Yeah. So the performance standpoint, we have IDC lab validation, not publishing by Red Hat. It's published by IDC. So IDC actually investigate Quarkus and Spring Boot, and then just the lab instruction. Okay, so there are sample application from Spring Boot and Quarkus, pretty much the same thing, and then doing measure some performance data for the throughput, response time, or a lot of metrics, and then that is actually available on the internet and publicly for free. You can find Quarkus IDC lab validation. So you can here, and then you can find that and download that PDF file for free. And then so for Spring Boot, like some comparison, because a lot of people ask the same question: why should I use Quarkus, and then what is a good thing Quarkus compared to Spring Boot? Or even if I can develop some of the application with Spring Boot, with some Spring like a Lombok or some Spring ecosystem, and then if I do the same thing with the Quarkus, how do I do that? And that is some kind of like a tutorial or some stuff. So Quarkus for Spring developers. You can search it on Google, Quarkus for Spring developer, and then from the Red Hat developer, there are ebook. My colleague and I, we wrote this book a couple of years ago. We're gonna publish the second edition soon enough. So this book actually downloadable ebook free, and then so there are few chapters like a use cases based. So how to develop REST services application, how to develop JPA application, how to develop like a messaging application and cloud integration, and then each chapter, and then showcase the sample application which is available Git repo and GitHub repo is available, and always we upgrade the latest Quarkus and Spring version. And then so that example here is how to develop, implement like a JPA with a Spring Boot Quarkus, and then we compare that, but we're not going to say which is better. So this is your choice, and after we do the book.
And like we have Spring initializer for starter project. You have
yeah, it's the same thing. So like I mentioned, the Quarkus.io, you can go there, and then here just start coding, which is like a Spring initializer. We say project generator, and then you can select more than 700 ecosystem, like a dependency Maven or a graduate module. You can also using some of the plugin extension, your ID tool, or Maven command line, Gradle command line, or Quarkus CLI, and then from here web page as well. Okay, and back to the demo. I just finished that, and then back to my terminal, and now you can see that keep running on the executor thread, which is the platform thread, and you can find my Daniel OTB here, the bin URL, and Daniel OTB. Here, I'm gonna bring that up. I actually brought up the hundreds of like a many video here, like a Quarkus, Kubernetes, and then like a serverless function and a lot of stuff. Yeah, feel free to subscribe and ask me anything around that. So I'm gonna stop my Quarkus and then go to like a reactive application. Let me try to run first the reactive application and then go back to my IntelliJ and then go to reactive application. So just like a code snippet, it's the just entity is the same thing, but the resources that you're going to change is some of the how to implement your continuation in the Quarkus way, and then pretty simple uni and multi stuff. And then so Quarkus actually automatically when I try to reload, and then you can see the different data here. So Quarkus acknowledges your application, if your application reactive on or non-reactive based on return type or annotation. So when you return like a uni and multi keyword, and then Quarkus just acknowledge, oh, your application reactive stuff. Let me run your application on event loop. If you return like a string or array, okay, you are not using reactive stuff. Let me try to run your application like some platform thread directly. Or you can put in the annotation explicitly like a annotation non-blocking or blocking. And then Quarkus, okay, you say non-blocking, which means the reactive app, blocking, which means the non-reactive application. When I go to terminal window, you can see that here, event loop thread is running on that. I'm going to just check it out, some of the stuff. And then you can see that keep running on event loop. So one last the app is to do a virtual thread. And let me try to run Quarkus first and go back to application. So here's a virtual thread application here. And then application exactly same, but I print some annotation and method label. And then here is like a non-blocking. This is like a non-blocking application. So something like that, similar stuff here. So one of the good things, Quarkus, you can actually implement non-reactive reactive application, both program model in the same application. So in the Spring Boot, actually, you need to rewrite reactive way or non-reactive way, separate project. But Quarkus actually, you can put into same project based on your some use cases. And then when I go back to terminal, and now you can see that go to load, and then introduce imperative versus reactive and virtual thread and Quarkus integrated loom, and then my Daniel TV again. And now you can see that. So virtual thread number 0 is running on that. When I click on some of the stuff, and now you can see that. So new virtual thread created number 1, 2, 3, 4, which is whenever got new request, you create a new virtual thread. Even if I create a yay, my demo works. And then I create a new one and I go back to here, the number 5 virtual thread just created for my new request. So that's really happening in the virtual thread. And then you can actually go to Quarkus Dev UI, which is a really good benefit. So the reason why I came here, the dev service is built-in test container, and then it actually hides your configuration. When you're using test container Spring Boot, what you want to do, you actually put in your configuration, like a test container, which container image I want to use. And then for that container, you need to add the required configuration. For example, database. What is my database URL? Like a JDBC URL, username, password. You need to set up, even if you're using test container. For Quarkus, actually, we hide this kind of stuff. So because you cannot find any configuration on your application properly, you don't need to even memorize this kind of stuff. But sometimes, okay, I don't need to use the default password of Quarkus. I need to my super secret password. In that case, you just copy and then paste to the application property or YAML file and change the value. And then Quarkus override automatically based on live coding the functionality. So maybe this is some good way to save your time for for processes. Okay, so right.
Web server, is it? Like, what are the app server options there?
What do you mean the app server?
Like default app server, like is Tomcat or?
Oh yeah, okay. So Quarkus builds on reactive engine, which is Netty and Vertex. So we're not using Tomcat, embedded Tomcat. So we have embedded engine, which is Vertex and Netty. And then just a reactive way, but you can still run non-reactive application on top of that. Okay, and also you can actually run like a Kafka topic stuff. I'm gonna just run one more Kafka thing here, and then Quarkus that. And then when you see that like a Podman process, which is a good way for alternative Docker. You don't need to pay for Docker anymore. The Podman desktop for free. And then if you find more information, please stop by Red Hat booth. And then we are more than happy to introduce. And then here, Podman process, you can see that exactly same thing. Not only PostSQL and then like Red Panda for like a Kafka and then Redis stuff here. And then it also running on virtual thread. And then when I go to welcome page, and then I can actually generate like a 2,000 transaction in a few seconds. And then you can see there's so many transactions happening. And then you can see more than like 3,734 virtual thread just created in a second on the virtual thread, even my local machine. So I'm going to stop here. We are running over time, and then go back to my slide deck. And then, so demo is done. So a lot of people, a little bit curious. Okay, you show really shining demo, and then fantastic, but you just show one annotation. That's it. Yeah, that's it. That's true. But in reality, you need to think about it more because Java 21 just came out a couple of months ago, and then a lot of Java ecosystem not ready to go the virtual thread yet, which means that sometimes you just import some of the library on your Maven and like a graduate project, but you don't know even what happened in there because you just import that library and use that based on API. But sometimes that inside the library actually broke and they're not ready to run your application on top of the virtual thread. One of the things is the pinning. So sometimes some like a, for example, like a transactional. So in the Quarkus side, we also provide the transactional annotation on top of the method, which allow you save your data. And then like almost a year ago, the Quarkus already have like a data transaction manager class, which also use synchronize keyword. The synchronize keyword automatically pinning your virtual thread to your platform thread. So, and then you're not gonna keep running virtual thread anymore. So it's JVM, go back to the worker thread, like a platform thread again. But you even don't know because you just run the one single annotation and you expecting your application running on virtual thread continuously. The functionality are still working. But sometimes, oh, I don't have any good concurrency level anymore because your underneath library actually broken. So that is one of the examples, synchronize block and manual log or supporting function. When you use that, and sometimes your virtual thread doesn't work anymore. So whenever you have a new Java library and ecosystem, you need to check it out. Hey, so you are already friendly with the virtual thread or not? Or some monopolization, like a long consuming computation programming model. So for example, even if you don't need to call external services, however, when you run your business application, they're very complicated application. Maybe sometimes it may be cryptocurrency or some kind of mining. It takes some time, not few seconds, maybe take few minutes or have like 1 hour. It still, it doesn't block your platform thread as a pinning. However, it actually keep using your virtual thread and your platform thread. But in the meantime, you got another request, and then your existing virtual thread and the platform thread is super busy. And then how to deal with it? Okay, let me try to create a new platform thread and to make it creating new virtual thread on top of that. So if you have a long running process on your some of the Java application, you make sure not going to running virtual thread. And then Java 21 provides a structured concurrency API, which is really cool because it's a parallel like a processing. You can actually split into multiple parallel processing and then join and combine the result, which is really cool. But the split process don't know what's happening inside the application logic at all. So sometimes some of the application just try to change some status, some specific status at the same time, like simultaneously, but it shouldn't be done. For example, like a data connection pool can be changed at the same time. So whenever you try to running like a virtual thread, like a structured API, you make sure your application logic should be thread safety. And then object pooling. So some people are actually familiar with the thread local, which is like some save your worker thread because when you store your local thread and then you can only access via like a local storage object, and then you're gonna keep reusing the existing thread rather than creating new one. It's just some like alternative way save your worker thread. However, as you mentioned earlier, the virtual thread there's not gonna reusing at all. You just creating, use that, and delete it and throw it. That's all. So if you have some thread local logic somewhere your business logic and the running on virtual thread and the virtual thread will be broken as well. And then container.
The last example which you showed, like where you are using virtual threads for two different functions, like calls, then you join the responses. It's similar to the completable feature.join, right? It is like which is more performant in that case? Like I'm just asking.
What was the question?
So can you go back?
This one?
Yeah, this one. It is very similar to how completable feature you do a supply sync and join, right?
Yeah,
Yeah.
similar thing. Yeah.
So like in the like just a question in terms of which is more performant in like with Java 21, is computable feature more CPU efficient or this is more CPU efficient?
I'm gonna ask that right after the session. We are running out of time, and then yeah, so I'm gonna answer that question. So one last thing is the like some container environment. So container environment, you have a very limited resources, CPU and memory numbers, and then at a time, sometimes you take some very limited memory resources. Even if you're gonna virtual thread, you're gonna keep creating virtual thread, but in the inside the container, very limited. Even if you keep trying to create a virtual thread, but you cannot because of limited container size. But so in order to you run Java app on inside the container on Kubernetes, sometimes you gotta have a good enough concurrency level based on container limitation. So luckily, Quarkus actually keep changing and create a pull request for Quarkus ecosystem, like a Kafka, gRPC, or messaging broker Redis. And then whenever we find some broken result from virtual thread, we create a pull request. And then some of the project, and then we have some authority merge the pull request right away. But some open source project, a lot of open source project, we can make them merge it right away. We're just waiting for reviewing and merging. Maybe take some few months, and then once they merge it, we're gonna get back to Quarkus library as well. But it's in reality, it depends on which Java library ecosystem you want to use that. So it takes some time to make available Java thread. So there's some benchmark test based on my to-do application on container environment. So here's a very interesting. So when you start your application between some concurrence level 1500 and the 4500, some level, so reactive application and virtual thread is a pretty good number, like a throughput, response time, and even resource utilization. But when you reach out to some number, like for example, 2200 concurrency level, and your virtual threads are pretty lower than even non-reactive application because sometimes it's a long learning processing or some of the like a container limitation itself. So let me go back to the beginning of the benefit of a virtual thread. Simple depth still true, and the resource efficiency and high concurrency, it depends on your concurrency level expectation and then your infrastructure environment as well. So that's why I'm going to show that finger crossed. Sometimes, okay, so I'm going to go to like a 2200 concurrency level for my Spring Boot or Quarkus. That's good enough. But I'm looking for the maybe 10,000 concurrency level. Maybe virtual thread is not good for that. So this depends on your stuff. So from now on, if you're still interested in starting with the virtual thread in your Java application, easiest way, maybe you can just start from Quarkus.io and then generate new project, and then just put on the starting the Quarkus, and then put on your run on virtual thread annotation, and make sure you use Java 21 rather than like a Java 11, Java 17. And then, so my session title actually road to a Project Loom in a really cheaper, faster, and then easier concurrency application. I'm going to ask you the question mark today because the answer should be different based on your infrastructure as well, concurrency level goal. So again, it's just scanning QR code. I already put on the old demo and a lot of stuff. feel free to subscribe and give me some any inspiration. I'm happy to create some technical tutorial. So that's it. And then tomorrow, Thursday, I have 2 more sessions with my colleague. He's still here, Kevin DeVore. And then we have a showcase open telemetry, observability stuff with the serverless and the Quarkus, of course. And then another session is a migration from monolithic application, the cloud-enabled application like a JakartaEE MicroProfile stuff using some like an open source tool. And we have more like a great session tomorrow and Thursday. All right, and thanks for joining today, and enjoy the rest of the conference.